Hi there, my name is Francis Eka, and for my class project I chose to focus on an interest of mine which is also becoming increasingly popular in the United States: Formula One racing. Formula One racing is the most popular form of motorsport in the world, consisting of 10 of the world's most prestigious car manufacturers including Ferrari, Mercedes, McLaren, and powerhouses of industry such as Red Bull. These teams create the fastest and most agile cars which can corner at a speed above 150 miles per hour, reaching their ever-changing top speeds above 200 miles per hour. These 10 manufacturers, called constructors in this context, appoint 2 drivers who race separately and in competition with each other, to make a total of 20 of the world's best drivers driving 20 of the world's fastest cars. The Formula One race season lasts from March to December and takes place in challenging circuits all around the world, which brings me to the specific topic of my application. When planning the Formula One tracking application, I wanted to base the application to conform to all the specified requirements stated in the project description. The main functionality of this application is to receive current Formula One race season information and display it in a table view format, allowing the user to select the race he or she is interested in and see a detailed view with more information on the race. The detail provided in this detail view can also include a map view, which plots the race location on the map, allowing the user to see the race in perspective of them and other locations near the place of interest. This functionality alone will cover the use of Web API to receive the information to populate each table view cell, which is an appropriate use of table view along with the use of map and location-based functionalities. In order to incorporate persistent data storage in the form of Firebase or core data and use the UI image picker view, I would also implement a user page in which a user information can be saved to core data, which can include a user picture to enforce the use of image picker functionality and requirement. The class diagram for my project is similar to the one I submitted for phase 1 of this project, with the addition of full information in all my UML classes and my model classes, along with the indication of my use of core data. The parsing of the JSON in order to populate the table view is located in the init function in the race calendar class, which serves as an array of the class race, which specifies what information will be needed for each race, that can be seen here. During the parsing of each index of the array, each index is populated with a newfound race, which can be used through the race calendar data of type race calendar called an F1 calendar view controller. On the top left of my class diagram, you can see that the F1 calendar view controller, which is connected to the F1 table view cell with an arrow to show a one-to-many relationship at the table, will have 20 to 22 cells depending on the current season of Formula One. Once the cell is selected, the user is traversed the race detail view controller, which is passed information through a segue and allows the detail view to populate its labels. The information passed also includes the race locality and country, which the CL geolocator can use to plot an annotation of where the race will happen. At this point, the user may pick a different view of the map with the map setting segmented controller or return back to the F1 race calendar table. Using the tab view controller, the user may also traverse the profile view controller, which is set up as a profile page with an image view for the selected user picture, labels to indicate name and location, and buttons to manipulate the view controller and the stored information in core data. If the user chooses to add or edit information, a button will bring the user to the Profile Edit View controller, which offers text fields for the user to input his or her information with previous displayed information filled into its respective text fields. Once clicking Save, the Save function saves the information displayed in the input fields into their respective core data attributes with a small text notifying the user that the input information was saved. From this point, the user may step back to the Profile View controller, activating an unwind segue which causes the Profile View controller to re-perform the ViewDidLoad function, updating the new information available in core data. From here, apart from the Add and Edit Information option, 2 more options are presented. The first being an option to update the user picture using the UI image picker, and the second non-highlighted option to clear all user data core data. If all information is cleared, the label representing the user's name and location will be set to their default state. The use of model view controller architecture promotes the use of separation between data retrieval, and presentation process, enforcing the minimization of repetitive code, and more structured approach when building more complex applications. For this project, I used MVC architecture to separate the housing of race information individually and as an array of all races in the current season. This, along with core data to handle user information, makes up the model portion of my project, which is updated when the user makes changes or additions to his or her information. The init function in the race calendar class performs a JSON parsing for the web API call to populate race information at the compilation of the project. My controllers include various controllers used throughout the project, including tab view, table view cells, and numerous text fields and labels. The view portion of the MVC architecture focuses on what is displayed to the user and includes a populated race calendar with selectable cells, a populated detail view, and a populated profile page with options for manipulation of the application along with text fields and other buttons provided the user with mobility. So I split my capabilities and my limitations into separate slides due to the sheer fact of how big each picture is coming out in order to be seen clearly in presentation. So my first capability slide here is the F122 race calendar. This will be populated with about 20 to 22 cells depending on what is the current season of F1. Each cell here will be labeled with the name of the race along with the name of the track. And once the cell is selected, it will take you to a detailed view, which will also display the name of the race and name of the track along with the race day. The race day information came in as not looking like this, and so I made a date parser function which takes in the date from the web API JSON response and returns it in a date format that is readable for us that we're used to seeing. The next thing displayed is the map view. This map view will take in the web API call location and country, or locality and country, and place an annotation or location marker at that place. You can also control the map by selecting standard, hybrid, or satellite through the segmented controller in order to change the view of how this will look. This is not the same race, but you can see how the standard will look and how the satellite will look. Will just be this without the hybrid markings. Under that will just be a text of just the name of the location. Okay, so this is part 2 of my capabilities. This is the second tab controller, the second view of the tab controller. This will take you to a user profile page in which the image and the name display plus the location will be set to a default, which can be seen here. Next, you'll be provided 3 options: add, edit, user information, update user image, and delete my information. The add, edit user information takes you through a segue to this page here, in which you have text boxes in which you can input your information and then press save my information. This will prompt a label to display if the information was saved into core data. Pressing back on this will take you back to this page with the updated information here. This happens through an unwind segue in which causes this view controller to redo the view did load functionalities in order to update the user information. Next option, you can also click the update user image, which will take you to a UI image picker like this, in which you can crop the image or choose the image and then crop the image. And once you press choose, this will also update here. Next, the last button will be delete my information. As this is using core data, all information is permanent and stored every time you load the application. And so this was a way for me to test my application and delete the information and restart and put in new information to test. The user can also use this functionality to restart their profile page or bring it back to the default icons displayed here. So this is my limitations page for my project. The first limitation that my project has is that the user has no required fields. the user can pick and choose which field to put information in and save the information, which will result to the information that wasn't added being defaulted to its default settings, or a hard-coded message by me saying that no name was added when it realizes that these two fields were empty. And so this can be fixed easily by including an alert, as we did in our previous labs, in which alerts the user that these text fields are empty or that now have information in them to be saved. Yeah. So another limitation of my project is the initial view at which the tab view controller loads into. Initially, I had it open to the tab 0, which is the F1 calendar, which displays the list of races and their circuits. But when I do this only on the first time I open the simulator in Xcode, it gives me this error right here, failed to log metrics. And then my research on Stack Overflow tells me that this is likely a problem with Swift to or Xcode to Internet rather than my implementation. But just to be safe, with the TAs or whoever's grading opens the project, I wanted to open on a page that is loaded. And so I had my submitted file open to the profile view page. And once that happens, this loads as well easily. So this is my lessons learned page of my project. First and foremost, I think the biggest lesson I've learned is the use of web API calls in the parsing of the JSON response that you get in return of the web API calls. This was one of the first times I was doing this, as we did do it in one of our labs, but it wasn't so personalized or challenging as the one I used for this. Another lesson I've learned is the use of tab controllers. I don't recall this being brought up in our class or through our semester, but I felt like this was a much easier way to traverse through controllers rather than through buttons and segues. Another lesson I've learned is like the overall picture of iOS web or iOS app development, and how like applications that we use today, such as Instagram and Snapchat and Facebook and stuff like that, that are also have been built in a similar way. It really allows you to see the bigger picture and see the workings behind some of the thought processes in what the developers used. So this is my suggestions and improvements page for the class project. I thoroughly enjoyed the process of this project and learning the web API calls and learning the inner workings of an iOS app, as most people use every day on their iPhone. I have no necessary modifications to the project itself, but a deeper dive into the JSON parsing and web API calls would have been greatly beneficial to how I would have performed, at least in this project, and for developing applications moving forward, because as applications get more complex, the use of web API calls is going to become fundamental.